Right, so we're now on the second part of the state space example, where we're now going to use the control law to get the closed loop state space equations. So the first thing I've done is, because we've got an extra state here and extra state here, because we've got two S terms, I've extended the states by 2. So I've gone from x6 to x8. So I've now got an 8 by 8 matrix here, and a 8 by 1 for the input mu. And the first thing we're going to do now is to, again, because these are the same number of poles and zeros, these are not ideally suited to a state space representation. So we're going to just convert these into two subblocks. So this one's quite simple to do. If we've got 6s plus 2 over s, we can know that as 6 plus 2 over s. So we can rewrite this box as a 6 and a plus 2 over s. So that one's going to be quite straightforward. So that's going to be a bit smaller. So that's giving us a 6 and a 2 over s. So we've rewritten the 6s plus 2 over s as 6 plus 2 over s, then put it in as that block diagram, and that should be a plus, shouldn't it, to be correct. And the next one's a little bit more tricky. The 3s plus 3 over s plus 10, we have to write as a plus b over s plus 10. So we split into a constant plus a fraction. So if we multiply everything by s plus 10, we get 3s plus 3 equals a into s plus 10 plus b. Now we can now do a compare coefficients. So coefficient of s is 3 and here is a, so a is 3. So that gives us the 3. Then this number is 3. 3 tens are 30, so 3 has got to 30 minus 27. So we could rewrite this as 3 minus 27 over s plus 10. So I'm going to take this box out here. I'm going to rewrite this as 3 and a 27 over s plus 10. And this time we'll put a plus and minus in here to give us the minus 27. And then when we've done that, we can call, say, this state here x7 and that state there x8. So x7 and x8 now are our additional states that we've got from our controller there. So we're now in a position to work out the control law and then get the closed loop state space equations. So we've got input signal here v, y is given by this term over here. So we could work out v minus y as 6 minus 6x2 plus 4x3 minus x4. So that's that signal there. And then we can start to work out the signal there, there and there. So if we get the different parts now, let's see how we should do this. If we've got the signal here, for instance, it's going to be 3 times this minus x8. So it's going to be 3 times this. So we've got 3v plus 18x2 plus 12x3 minus 3x4 minus x8. So that term there is going down there. We've got an x5 here, so this term has got a, and that's going to be a plus and minus there. Let's put the minus in properly. So we've got minus x5, so that signal there now is going to be the same as this one, but it's got a minus x5 in. So this signal here has got a minus x5 in. and then that whole thing then gets multiplied by 6 and added in by an x7. So it gets 6 times this now. So that's going to be quite easy. So 6 times that will be 6 3s are 18v. 6 18s, 6 8s 48, 104 plus 104 x2. Then we've got 6 12s 72 x3 minus 6 3s are 18, 18 x4 minus 6 x8 minus 6 x5 plus x7. So this signal here now is what's going down there. So this is actually our control law, U equals. So there's our control law now, and what we're going to do now is to put the control law U into here. So we've got a 4U here. Notice we've got a 4 there. So a good idea now to be multiplied, work out what 4U is. So we get 4U, can you start here maybe? 4U, we're doing 4U because we need 4U over here. So 4 18s are 72. 4 of these will be 416. 4 72s will be 288. 4 18s will be 72. 4 6s are 24. 4 6s are 24. And 4 times 7 will be plus 4x7. So this is 4U now, which is our, and this is our control law, because we worked out what that signal there is. So we now put these numbers now into the control law, but before we do that, we'd also be wise to get a little state space equation for this one and for this one and put those two equations in here. So I've missed out on that a little bit, but we can do that quite quickly. So let's just rub this bit here out. I'll keep our control law, having derived it. So let's look at this one here now. X8, we've got a little box, quite a complicated input. We've got V minus 6x2 plus 4x3 minus x4 going into the box. And out of the box we've got x8, and this is 27 over s plus 10. So now we've got this is this times this, so get the x8 will be, or x8 multiplied by, so x8 is equal to 27 over s plus 10 into v minus 6 x2 plus 4 x3 minus x4. And we can move the s plus 10 up here, so we'll get s plus 10 times that, and then we get s times x8 is x8 dot, so we'll get x8 dot 27v. Then we've got 6 27s, so 6 times 42, 12, 14, so 144, so it'll be minus 144 x2. Then we've got 4 27s, so 4 times 27, 28, 808, so that's going to be plus, so it's a sign wrong there, isn't there? That should have been a plus there, that should have been a plus there, sorry. And there's a plus there, so that's a plus there, so that should have been a plus. Spot it down. Plus, let's go back to 4 27s for 108, 108 x3, and minus 27 x4. And and then we can bring over 10x8 as well, so this will be minus 10x8. So here's our x8 equation now. It's got a v term in, but it's got 144x2. So it goes on the bottom line, x8, so 144. So you've got 144 in there, 108x3, 108 in there, minus 27x4. So you can leave a minus 27 there. 10 minus 10x8, so it'd be minus 10 in there. And we've also got a 27v, so I have to add in now an extra slot in here. One, two, three, four, five, six, seven, 8. There's our 8 boxes, and we want a 27 here. So it's going to be a 27 down there. That's a 27 multiplied by v. So there's our state space equation for x8, and then we need to do the last one, which is x7. So x7 is this one here. So we've got a little box, 2 over s, x7 coming out, and into it now we've got this term here. So this term is a little bit more complicated, so I have to go back to this one. It's going to be this part here, which is going to be it's going to be x8. Let's try as x8. So it's got an x8 coming that way. It's got a minus x5, and it's got this signal here, which is, well, it's got the x8, so it's 3 times this. So it's going to be 3 plus 3v plus 18x2 plus 12x3 minus 3x4. So this is a bit more complicated, this one, but because it's a 2 over s term there, it isn't too bad. So we'll get this is this times this, so we'll get that x7 equals 2 over s multiplied by these terms here. So that would be 3v plus 18x2 plus 12x3 minus x5 plus x8. Move this s term up here, so that will become x7 dot, and then we can multiply everything by 2. So 2 3s are 6, so that will become a 6. 2 18s, 36. 2 12s, 24. 2 will just go in there, and a 2 will go in there. So here's our last equation, x7 dot equals 6v. So x7 dot will be 6v. It's going on the 7th line here. 36x2, so I have a 36 in here. A 24x3, so I'll go in there, and minus 2x5. 1, 2, 3, 4, 5. So minus 2 in there, and 2x8. So I've got a 2 in there. It's got a 2 over s there, so it looks correct. So there's our full state space closed loop system. Other than now, we've got to put 4u now. 4u is going to feed in here, and that's going to feed in on this line here. So we're going to do that in a different colour, just to highlight the change. So let's have a look at this now. So 4u is equal to 72v. So I'm going to put a 72 in here. That's the first one gone. Then we've got a 416x2. So we've got 416 in there. That one's gone. We've got 288x3. So that one's gone. We've got minus 72x4. So that one's gone. Got minus 24 or minus 24x5. So that one's gone. Got 4x7. 4x7s. And we've got minus 24x8s. Now, because we've done that, we've actually replaced now the U, the 4U. So the 4U has disappeared. So that means this part here has disappeared. And these now represent the closed loop state space equations. So the general technique is obtain your open loop state space equations. Then, if you've got some controllers here, simplify these into rational forms. Add those in as extra states into your closed loop state space equations. Then derive the state space equations for these individual bits. Add those in. Then when you've got those, start over on this side. Follow the control signals round and work out what an equation for the control law here by working out this part, then that part, then this part, then that part, then this part and that part, adding them together and eventually get an equation for U. That'll give you your control law. And then watch out for, and there's a 4U there. So work out what that number is. In this case it was 4U. Then that gives you your complete control law. And then these numbers then feed in on the particular line on your U. And that will give you your complete closed loop state space equations. I'm back again on this thing. I just double checked my answers and there's small numerical errors. That one should have been 432. That one should have been minus 6 and that should have been 162. No one here to tell me my small mistakes, but I hope now it's the correct answer. Good luck.